Okay, today we're going to be having a look at our next type of graph, which is called the hyperbola. You should be fairly familiar with these from your year 9 and 10 content. Okay, so hyperbola is a function that has an equation that we can think of as being in two forms. This first one, xy equals a, or if we divide both sides by the x, it would look like y equals a over x. So when you see any function that has an x on the bottom and a y on the opposite side of the equal sign, we're going to look at that and go, okay, that's a hyperbola. Now, the general or most basic hyperbola that you would have seen before is y is equal to 1 over x. It's a positive hyperbola because there's no negative signs in there. And the most important thing to think about in this hyperbola is what's happening on the bottom line underneath our division bar. We cannot divide by 0. So in your calculator, if you popped in 1 divided by 0, you're going to get a maths error. Okay, it's mathematically impossible for us to divide by a 0. So what we say is x cannot equal 0. We're going to always write that down, and that's where our asymptote is going to happen. And in this case, I'm going to think of it as if I had my function as x, y equals 1, and I had x equals 1 over y cannot equal 0 either. Okay, so y equals 0 is also an asymptote. So because neither of these can equal 0, they're our asymptotes. So if you remember what an asymptote is, it's a line that exists where our graph will not touch. As our graph gets, in this case, we'll have a look at the shape of it in a second, I guess, but as our graph gets bigger along our x-axis, it gets closer and closer and closer to our x-axis, which is our asymptote, which is our y equals 0, but it never actually touches it. So that's what happens with an asymptote. Our graphs get lots and lots and lots closer to it, but it never actually reaches that line. So our y equals 1 over x, we said was a positive graph. And when we have a positive hyperbola, our two arms are happening in our first and our third quadrants. As opposed to, if we have a look at our next graph over here, the sketch of y equals minus 2 over x, it's a negative hyperbola, and those parts of our hyperbola are going to occur in our second and our fourth quadrant. Okay, so positive, first and third, negative, second and fourth. So let's have a look at this second hyperbola, y equals minus 2 over x. We know it's a hyperbola because there's an x on the bottom, there's a y up here. We know it's negative. So we've got these two quadrants. We know x cannot equal to 0. So that's one of our asymptotes. And y cannot equal 0. So that's another asymptote. We have a 2 on the top line here as opposed to our 1. What the 2 does is just move the graph further away from our asymptote. So if that was a minus 1 over x, our graph would sit down here and up here. So the 2's just pushed it a little bit further out from our 1 over x. Need that one in there. So it's just pushed the 1 over x out to become 2 over x. So the 2 just makes it bigger. If we had 3 over x, it would be a little bit further out again. Okay, so we're going to move down a little bit in our booklets now. We're going to look into transformations and symmetry. We're currently moving into chapter 5, and we've had a look at some of these movements previously. We'll come back to these, circles and square root functions, but we're going to have a look down here at the hyperbola. Now, this might look a little bit familiar, and that's in our actual booklet that I gave to you last week. So I'm going to just move over into that booklet. It's in our OneNote under booklet. You've all got copies of that. So I'll pop that up. You can copy that back onto your other sheet, or you can read it from here. So the hyperbola, we've said here's our basic form, y equals a over x, and have a look at these types here. Y equals 1 over x and y equals minus 1 over x. If it's positive, like I said before, our parabola is in the first and the third quadrant. So that's this one here. If it's a negative, it's in our second and fourth quadrant. So we want to have a look now at some of the different variations of things that can happen. Over here, we've got y equals 1 over x plus 1, y equals 1 over x plus 3, and y equals 1 over x minus 2. Okay, so the only difference from these parabolas in our second row to our first one is we've added on a number or taken away a number. our plus c or our minus c. And what that plus or minus value does is moves our graph up or down the y-axis, just like our quadratic or parabola did. If we're going +1, we're moving our normal hyperbola 1 up on the y-axis. If we're going -2, we're moving our normal parabola up here down -2 to -2 on the y-axis. So that's what those numbers at the end do. So what actually happens in each of those cases is these numbers are becoming our asymptotes. So y equals 1 will become an asymptote, y equals 3, and y equals -2 will become asymptotes. We're still going to have x as 0 on each of those as asymptotes as well. And we'll have a look at how those get drawn in a moment, and we'll draw some up together. Okay, row 3. We've got y as 2 on x, 5 on x, and 20 on x. So that's a generic form, y equals a over x. We've had a little talk about this, but what that number on the top does is moves our graph away from the axes, or it's moving our graph away from our asymptotes and getting further out. So 20 over x is going to be further out from our asymptotes than 5 over x is, which will be further out than 2 over x is. Another good way to have a look at those is to go and plot them on Desmos, but again, we'll draw some in a moment. Our fourth and final type here, we have expressions on the bottom line of each of them. So a +2, a +3, and a -1. And it's saying here that it moves the graph along the x-axis. But what we want to think of in each of these terms is what's happening on that bottom line. Remember how we can't divide by 0? Well, we still can't have 0 on the bottom line here. So x plus 2 cannot equal 0. So if I take 2 away from both of those sides, x cannot equal -2. Because if x was -2, I'd have -2 plus 2, which would be 0. So that's our asymptote. X is equal to -2 and y is equal to 0, because we haven't added any value on there to change our asymptote for y. X plus 3 can't equal 0, so x cannot equal -3. And on the final one, x minus 1 cannot equal 0, so x cannot equal 1. Y can't equal 0 on each of them either. Okay, what we want to do is have a little go at drawing these three. Okay, so we've got 1 over x, x plus 2 minus 2 over x, and 1 minus 3 plus 2. Okay, if you jump over to the OneNote again, you'll find an actual graph of what we did of those in the class today. That's what they're going to have a look at, or what they're going to look like. But let's have a go at drawing them ourselves. Okay, but you can flick back to there and have a look if you're interested. And we're going to flick over to there in a moment ourselves. But let's get that drawn in here. Now, it's actually in the booklet. So if you want to go to the booklet and have a look at that, you can. Or else just copy that onto your page. Let's go find it again. And you can just sketch up one on your page. So y equals 1 over x. Now, remember, we're only sketching these. We're not looking at making them plotted. We're just sketching them. So let's draw y equals 1 over x. I'm going to do that one in red. So that's going to look like this. It's our basic form. I better write the asymptotes up there. We can't divide by 0, so x cannot be 0, y cannot be 0. So our axes, x-axis and y-axis, are our asymptotes. That's what our first graph would look like. Nice simple one, and you need to know that off by heart. The second one, we look at it, okay, we know it's a hyperbola, we know our bottom line, x plus 2, cannot equal to 0, so x cannot equal -2. So if we pop, there we go, -2, I'm going to dot our asymptotes in there. So what we have for that graph is x can't equal -2, so that's an asymptote. We haven't changed or played around with y, so y cannot equal 0 is also an asymptote, and that's our x-axis, okay? Because y is 0 down here, y is 0 along all there, and all there. So that's our asymptote, y is 0. So what this graph is going to have a look like is it's going to cut through here. It's going to go down here as well. Now, another thing we can do for this graph is discover where it's actually going to cut the y-axis here. And it's going to cut the y-axis when x equals 0. So if I pop a 0 in there, I'm going to get 1 over 2. So it's going to cut the y-axis, yeah, at a half. So let's grab a different colour for that one. We might go green. it's going to look, oops, like that. And, oops, a bit messy there, like that. That's our green one. Okay. Rightio, so they were both positives. Let's have a look at our third one here. This one here. It's a negative hyperbola. It's a -2 on the top. So we're going to be sitting our parabola in this quadrant and this quadrant. Now, I'll just change back to a different colour. Let's go grey this time. In this case, our asymptotes are x equals 0. Because x is on the bottom line, we can't divide by 0. And y is going to be equal to 0. So our asymptotes now are the y and the x-axis. So we're not using the -2. We're just going to be a little bit further out than our red one was. So we're going to have it looking like this. And that's our -2 over x. One lucky last one to go. We might pop that one in another colour. Let's go black. Okay. Now, bottom line. X minus 3 cannot equal 0. So x cannot equal 3. Y plus 2 is also an asymptote. So y cannot equal 2. Okay, so let's add that to our graph, our asymptotes. X equals 3 and y equals 2. So x equals 3 is down here, 1, 2, 3. So I'm going to draw myself some asymptotes in here at 3. And y equals 2 would happen up here, 1, 2. And we'll draw asymptotes in there at 2. Rightio. So what you can see now is we've got a quadrant up here, and we've got a quadrant down here. And our graph is going to sit in there because it's positive at the top, okay? So I'm going to pop my graph in there like that. I've got another one that's going to fit in there like that. There we go.